Does everybody know what ETO is? It's engineered to order. Okay, it's engineered to order product, and these are all things that I've worked on, companies I've worked for in the past. And basically what engineered to order is, it's usually one-off. It's usually heavily or partially influenced by the customer, and it's usually a challenge from a lean perspective. Not so much from a. It's actually ideally suited for TOC. But these are some of the things I've worked on. This is a big industrial pump. That was for Sulzer, and there's a Swiss company, but we manufacture. Actually, this is the diesel engine that drives it. There's the pump there, but we made the whole skid. That's a tunnel boring machine. We didn't make that one. I just got that picture off the internet. But one of the companies I worked at, we built the tunnel boring machine that bored from England to France. And then this is a blowout preventer. This stops oil blowouts. That's an above ground unit. We also made subsea units. And then this is a missile launching rail car. So those are just a few of the things I've had a chance to work on in my career. And I've applied, with the exception of this one, I didn't get heavily involved in this one, but the other three, I applied the theory of constraints to heavily. Okay. You know, one of the early in my career, I worked with a lot of consultants. I was in industry myself for about 27, 28 years, and I started consulting about 4 years ago. I started as a manufacturing engineer and worked my way up to CEO. I spent about 10 years as a CEO, but I've always used TOC in every company I've been in. I usually hire consultants, TOC consultants, to come in and help me now, and I did in most of the companies that you saw. But when I first went to a company called Danley, they had some recent Harvard graduate MBAs in there doing a lean implementation, and it wasn't going so well. And I had just started with the company. The owner of the company asked me to go to this plant. He said the people were resisting the change, that they weren't buying into the lean concept, or the lean concept that they were being taught. So I went in there, I flew up there. I went to the plant. I talked to the consultants first, and I asked them, I said, what's happening? What are the issues here? And they said, well, we're trying to put a Kanban system in here, but the lead man on the floor is resisting the change. And I said, well, let me go walk out on the floor and take a look, and I want to go talk to the gentleman and learn a little bit more about the process. Well, they'd put Kanban squares in that were about maybe as big, maybe twice as big as this computer here, but the parts they were making were probably 3 times as big as that sign. They brought the first part in and it covered up all the Kanban squares. It was the wrong tool to use. And so the owner called me and goes, how did it go with the guy out on the floor that's resisting the change? And I said, well, I've got some good news and some bad news. The guy on the floor that was resisting the change was right, and your consultants were wrong. We need to get rid of the consultants and bring somebody else in. So we got a local TOC consultant in. We put drum buffer rope in there, and that plant was able to double its output, not add anybody else, and significantly reduce the inventory. And it was also an engineered to order company. That company was able to take because these were all customer engineered products. They could take a customer engineered product, take an order Monday morning and ship it Tuesday afternoon. That's how fast they were. That's how fast they got. Okay. I haven't been in an environment yet where TOC isn't applicable. I've been able to use it everywhere. When you're going in to fix, I usually end up going in and fixing manufacturing companies now. And I have to choose the right tool. And one rule that I use for choosing the right tool is I explain the tool to the people that have to use it. And if they can't repeat it back to me and understand it, then it's the wrong tool. I just can't use that one, because if they can't grasp it quickly, it's probably not going to work. Okay? Nomenclature, I don't know if this is an issue in Germany, but it can be an issue in the US. There's been a lot of failed lean implementations, and there's a lot of negative connotations among the hourly workforces in companies where they've had failed implementations. So I don't use any of the buzzwords when I go in and implement change. The SQDC, that's something I use when I go in to fix a manufacturing plant, and that's safety, quality, delivery, cost. That is the priorities I use to to fix any plant. It works anywhere for me. Oh yeah, yeah. It's safety, quality, delivery, and cost. Okay, make sure that the plant is safe first. Most of the plants that I go in these days, they've usually got pretty good safety programs, and I don't have to focus much effort there, but sometimes I do. Quality is a given in most plants these days. But still, there are quality issues, but you have to fix those first before the company's going to be healthy, and then we work on delivery and cost. You can work on quality and delivery at the same time, though. It's not sequential. You can work on them in parallel, okay? Or I can. Okay. Sales forecast. Every ETO company I've worked in, people complain about the sales forecast. It's never accurate. Well, it's never going to be accurate. Engineered to order product is very hard to predict the sales of. It follows the economic cycle. I have my own engineered to order company. I make automated deburring equipment for automotive companies. And I can't predict the sales of my company, and if I can't do it, I don't expect anybody else to be able to do it. So I don't worry about the sales forecast for ETO companies too much. I worried about their past sales and what the current level is, and then where they're at in the economic cycle. Okay. And you should always know that, where you are in the economic cycle when you're in an ETO environment. In the US, the professional groups, almost every one of them once a year brings in an economist and tells you where you are on the economic cycle. And I would imagine you have the same thing here in Germany. I have a picture of one at the end, but I'm sure most of you have seen it. Know what your customers want in terms of lead time and be the best. That's probably been the most competitive weapon that I've had in ETO, is being faster than the competitors. You're going to get orders because you're faster than anybody else. And I'll talk about a couple of examples that I've had in my career where that really pays off. Make or buy, that's a big decision in ETO. You can have a lot of idle assets in an engineered to order company. So you got to be careful of what you decide to make and what you decide to buy. Usually in every case so far that I've been in, we've always chosen to make sure that we assemble the product that we make. We've always staffed to the low side of the economic cycle too. And then we ramp up the staff with temporaries when the economic cycle turns up. Like I said, we make strategic use of temporary help, and I've seen some of that here in Germany as well. Back up your constraints. In every ETO environment, there's usually one major constraint. It's usually either an intricate design or a proprietary product, but you have to back that up, because when you're at the top of the economic cycle, it can be difficult to satisfy market demand if you don't have that backed up somewhere. Okay. Supply chain. This is probably one of the most important functions for a well-run ETO company. Your suppliers are critical to your success. Don't choose them on price. Choose them on cost and fit for your company, and how well they integrate with your manufacturing process. Working capital is also very important, especially if you're not a publicly traded company. If you're a small to mid-market company, working capital is extremely important. You want to keep those inventories as low as you can, get your payables right, and stretch your receivables as much as you can. Understand the constraints in your supply chain, because you may have to go fix your suppliers. I had to do that at Sulzer. We had a casting supplier. They were taking 12 to 16 weeks to make the castings, and we searched the world over and couldn't really find anybody to do it faster. So we said, well, we have to go in and teach these guys TOC so that they can deliver these castings faster to us. We actually helped them quite a bit more than that. When we got there and offered our help, they were proud of the fact that they were going to build a $1.5 million rework facility to rework their castings, and we said, "Well, let's take just a smaller portion of that money and fix your process, so you don't have to rework your castings." So we helped them with that too. It's hard to do that if it's a very small company. If you're a mid-market or larger company, you usually have some assets, internal people that can help with that. A small company, it's more difficult to do that. The manufacturing operation, how to select what you make or buy. In every one of those companies, there was always critical parts that they were either proprietary or they were very difficult to make and very hard to outsource. Those are the ones you want to keep in-house. And you all know how to find the constraint quickly. You need to manage that constraint like it's a pot of gold. The pump company that I mentioned, we spent about $1.5 million just setting up the buffer for that, or setting up the buffer system for that constraint, but it paid huge dividends. Okay. Assembly management, assembly is where you want to use a lot of temporary people, and bring in the temps to do the lower level jobs in the high cycle, and not lay off your people in the low cycle. You want to keep a core workforce in an engineer to order environment. Preparing for assembly, this is another, it takes a lot of work. What most companies do in engineer to order environments, everyone that I've been in, they trickle the parts into assembly. And it causes a lot of delays in assembly. And the reason they're trickling the parts in is because the purchasing is not synchronized with the manufacturing. And it also adds a lot of cost to the assembly process, because they're stopping and starting, they're looking for parts. It's a huge waste in engineer to order companies. So what we have done in more than one case is we made a rule. The kit has to be complete before you release it to assembly. The first time we did that, we got a 20% reduction in assembly time. But that kit has to be complete. Don't release it too early. There are instances where it doesn't have to be complete, and that is when you don't need one or two of the parts until the part is ready to ship. Okay? But for the most part, have everything ready for assembly before you start. Don't start too early. What are the best tools for ETO operations? TOC is by far the best tool that I've used. Drum buffer rope was a huge help to me. Critical chain is also very important. I'm going to talk a little bit about that when we get to engineering as well. And then 5S works in any type of environment, but typically in ETO it works really well as well. Engineering, you know, in the US, I don't know if it's that way here, but typically in an ETO environment, direct labor is 10 to 15% of the cost of the product. And where do the accountants spend all their time looking for ways to reduce cost? They focus on that 10 to 15%. And that's what happens in the US. I don't know if it happens here. But that's not where all the money's wasted. The money's wasted in the supply chain and engineering. And that's what you have to measure that as much as you measure the rest of the manufacturing organization. Engineering especially, they're going to be the ones that are going to cause you to be late in shipping your pumps on time, many times. The measurements that we put in place for engineering was on-time engineering drawings to the manufacturing floor. The other one we had was the number of changes that were issued after the release of the bill of material. But you really need to measure your engineering function. They don't like it initially, but once they see how they are and how much better they can be, they become okay with it. If you can co-locate your engineers with your assembly operation, that's the best way to go. But you really need to measure your engineering function just like you measure your manufacturing function. And the same with your supply chain. Excellent opportunity. ETO is an excellent opportunity for critical chain from the first time the customer calls till the time you ship the product. There's just, in most ETO companies I've walked into, I've never not been able to reduce the lead time by 50% or more. There's that much waste in most ETO companies. You can, at Sulzer we got as much as 80% of the lead time out of the product. Whoops. Oh, there we go. Inventory. Highly complex engineered products. Usually when you're done assembling them, there's a bunch of parts left over. And what do most companies do with those parts? They put them back into inventory. And what happens to them? You count them every year, and then 10 years later, you throw them away. So what I'm proposing to you and what I've done in other companies is you disposition them when the pump ships, and they get charged to the job. Right now, what happens to a lot of companies, they don't charge them to the job. They put them back in inventory, and they don't know how much that job really cost them. And one issue I found was a company had a significant amount of leftover inventory on one product line. They didn't know it. And who went in and looked at it, their margins were actually a lot worse than they thought they were. So it's very important that you get rid of that inventory. And there's several ways to do that. When you're in an ETO environment, whenever you can, order your parts out of a catalog. Try not to engineer them. In my own company, we get everything out of a catalog. If we can get it out of a catalog, we do. We search catalogs. Misumi, McMaster-Carr, there's a lot of good catalogs for building machinery. Get it out of a catalog because you can return it if you don't use it. You're going to pay a restocking charge, but it's better than writing it down to zero if you made a special unit. So, what should you stock and how should you stock it? Buy everything to the job. Don't buy it to inventory. A lot of companies will buy full bars of steel and cut it up and use it. They'll have leftover steel. A lot of companies have a fabrication operation. They burn shapes. They can't manage remnants because they don't cut enough steel. The service centers can do a lot better job of that than the manufacturers can. So I would highly recommend not getting into those type of operations or avoiding them. The service centers have come a long way in the last 15 years. They'll do a lot more for you now than they would 15 years ago. And they'll take a lot of cost out of your operation. What's that? Yeah.
Making components for helicopters.
Yeah.
And on contract base, we had to put resistors, capacitors, IC components, whatever.
Yeah.
Used in that helicopter on stock for at least 20 years.
Yeah. there are instances when you're going to have to stock parts. The Defense Department is one. I was in the nuclear industry, and we had to stock parts for them, and we had very tight material controls for what we bought, and the certification we had to keep were very high, but the margins on that product were above 60%. So we could allow ourselves a little bit of the inventory that we were required to keep. In normal ETO environments, when you're competing with other commercial manufacturers, your margins aren't quite as high as they can get with say aerospace and nuclear. Okay. What do you do with all the stuff you have? When I come into companies, I don't get called in because they're running so well. Usually I do an analysis of the inventory, and you have to make a disposition on that stuff. But don't keep it. Start figuring out what to do to get rid of it, and get the rules in place to stop from growing it again. Maybe you're cutting material up to put in your lathe, and you're buying full bars, but you're stuck with remnants all the time, or it sits in your inventory for a year. Don't buy full bars anymore. Buy it cut to length. There's a lot of different things you can do with the supply chain, especially now. They've gotten so much better. They're so fast at delivery now. You really need to leverage the supply chain in an engineer-to-order environment. Okay. Quality, build quality in, no inspectors. Most companies, with the exception of aerospace and nuclear, you have to have inspectors. In the nuclear industry and the aerospace industry, you're required to have inspectors because they have 100% as-built drawings that you provide all the dimensions for, and other reasons. But in most commercial companies, you really don't need inspection. You need to build the quality in. Okay. Suppliers, incentives for quality and penalties for defects. A lot of the companies I work in, they don't measure their suppliers very closely, or closely enough. On-time delivery, and that means delivering too early or too late. They need to know that it's not okay to ship you defective products, because when you shorten that lead time, that becomes so much more important, that the quality of your suppliers is better, and your lead times, they deliver in a very narrow window. Most companies that I come into maybe have a 10 to 30 day window that they allow their suppliers to deliver into. And we have to narrow that way down to 4 or 5 days, and you can narrow it down closer than that on some products. Contracts. Have any of you been in ETO before? Engineer to order environments? Oh, okay. Yeah. Well, what happens? Customers always love to change things. And a lot of companies I go into, they don't charge the customer for those changes. You have to charge the customer for those changes. It's very painful, and this has to come from the top down. This has to come from the CEO, and he has to drive the sales group to make this change. With the A&E, the architect engineering firms, it's easier to do because they're used to that. But the non-A&Es, they're your long-term customers. It's a little more painful, but you have to break that barrier and start charging them for those changes. Okay. Customers want penalty clauses too in ETO. I don't know if you guys have run into that. Well, when I get the engineer to order company fixed, we love those penalty clauses, because we say, we'll take the penalty, but we want a bonus for early delivery. And it's weighted the same way that the penalty is. Okay? And most of them will give it to you. Yeah. I think that's about it. Oh, no. And when I got my first introduction to TOC, I was trained by Bob Fox, and at Honeywell, it wasn't Honeywell then, it was Allied Signal back then under Larry Bossidy. But Bob Fox was our trainer. We went through that old DOS-based the simulation. I don't know if any of you went through that many moons ago, but he was a great educator. He taught me a lot. But before he taught me that, I probably wasted well over $1 million of other companies' money buying capital equipment that we didn't need, you know. I was buying capital equipment that had no effect at all on the constraint. Satisfied the consultant, or not the consultants, but the accountants. You know, I was able to take some labor time out of an operation and show them that I was able to reduce the labor hours, but it provided absolutely no extra sales. You know, it did nothing for the company, but I spent $1 million of their dollars, and they gave me a bonus for it. So he was the guy that taught me not to do that. And I felt pretty bad for the couple of days after he taught me that. I go, man, I really screwed up some other companies, but it's been a valuable lesson to me the rest of my career. Oh, that's just the economic cycle. I'm sure you've all seen it, but I just added it in there for an appendix. One other thing I'd like to mention is about 10 years ago, I got a call from Ellie Goldratt, and he came to one of my plants in Cleveland, Ohio, and I got to spend a day with him, and boy, was that an experience. That guy is probably one of the more interesting guys I've ever talked to in my life. And it was right after he wrote that It's Not Luck. And he was using me as a test market for his sales process for selling the, I don't know if you guys remember, he was trying to get into selling ERP software with a TOC link to it, but we got to talking about our plant, and we took a plant tour, and boy, I felt sorry for his secretary, though. That lady worked so hard. I mean, he kept her busy the whole time we were there. But just an amazing guy to be around. That's all I have. So.